This is Engineer Nasir from NC Engineering and Technology. I welcome you to our series Primary, Secondary, Tertiary Chillwater Pumping System Part 3. Friends, if you are new to our channel or still you have not subscribed it, please subscribe to our channel so that we can bring more videos for you. In HVAC chillwater distribution system, there are 4 commonly used chillwater pumping system. They are as number 1 constant volume primary chillwater system, number 2 variable flow primary secondary chillwater system, number 3 variable flow primary secondary and tertiary chillwater system, and number 4 is the latest one, that is variable flow primary chillwater system. Number 1 and 2 we already studied in part 1 and part 2. So today we will study part 3 variable flow primary, secondary and tertiary chillwater system. Let us study what is variable flow primary, secondary and tertiary chillwater pumping system. When the buildings to be served are distributed over a large area such as university campus, then so-called primary, secondary and tertiary chillwater scheme help to reduce pump pressure in the system. By splitting the system head between secondary and tertiary pumps, excessive pressurization in zones which don't need high pressure is reduced. In these systems, all cooling coils or building loops may be served by a third set of pump. We call it tertiary pump. These distributed pumping systems are well suited for large multiple zone buildings or multiple building systems with central energy plants. These systems are actually a collection of smaller systems operating independently of each other, but all of them use the same distribution piping and the central chiller plant. The primary side of the system is usually confined to the central plant where chillers and pumps are looped together, while the secondary loop distributes the chill water to outlying buildings and the respective tertiary loops circulate chill water within the building. A primary, secondary and tertiary chillwater pumping system basically consists of 3 parts. Number 1 is the primary loop. The primary loop is usually confined to the central plant where chillers and pumps are looped together. These pumps are constant speed chillwater pump, normally with low head only, responsible for the chillwater flow through the chiller. The secondary loop basically is the chillwater piping network between the chiller plant and the building to be served. It is responsible to distribute the chill water to outlying buildings. The chill water pump in the secondary loop is variable speed chill water pump controlled by the variable frequency drive. The operation of primary and secondary loop in primary, secondary and tertiary chill water pumping system is exactly same as of primary and secondary chill water pumping system that we already study in part 2. Normally there is difference in piping material for secondary chillwater piping loop. In primary secondary loop, the complete piping network is within one building, so the normal black steel pipe with normal insulation can be used. But in case of primary, secondary and tertiary chillwater pumping system, we have chiller plant located far away from the building that is served by the chiller plant, and the secondary chill water piping normally it is underground buried pre-insulated pipe with leak detection cable. This leak detection cable is connected at the end to a panel where we can see the leakage in case it happen. You can refer to our tutorial for primary, secondary and tertiary chill water pumping system part 2 to understand the concept for primary and secondary chill water pumping system and their operation. Now we will study tertiary loop of primary, secondary and tertiary chill water pumping system. Tertiary loop we can divide into 2 types. One having a decoupler line at the interface of secondary and tertiary loop. The second one is having heat exchanger at the interface of secondary and tertiary loop. Let us first understand the tertiary loop with decoupler line. This type of decoupler loop work exactly same as the secondary loop. It has variable speed chill water pump equipped with variable frequency drive that got the signal from differential pressure sensor at the end of chill water piping network and varies its speed as per the requirement. As the cooling load inside the building is dropped, the two-way valve receives the signal from the thermostat inside the building and it restricts some of the chill water to flow through the HU, and it develops a differential pressure sensor between the chill water supply and return network. This differential pressure is sensed by the differential pressure sensor, and it sends the signal to the variable frequency drive to slow down the chill water pump. This low demand of chill water in the tertiary loop inside the building is sensed by the two-way valve in the secondary loop, and there is differential pressure at the end of chill water piping network in the secondary loop, and it sends the signal to the variable frequency drive fixed with the variable speed secondary pump, and it slows down the pump to regulate the chill water flow as per the requirement. In this operation, there is 2 points to be noted. First one is when the two-way valve in tertiary loop receives the signal from thermostat, it restricts the chill water and it gives the signal to the tertiary variable speed chill water pump to control the flow, and as a result this tertiary pump controls the chill water flow inside the tertiary loop. After this, the two-way valve located at secondary loop senses the less demand of chill water in tertiary loop and sends signal to the variable frequency drive to slow down the speed of secondary chill water pump to maintain the chill water flow as per the building requirement. But there is a delay time between the tertiary chill water pump and the secondary chill water pump to maintain its flow as per the building requirement, and during this time there will be some excess of chill water flow from secondary chill water loop to the tertiary chill water loop, and this excess chill water is bypassed through the decoupler line. This type of tertiary loop normally we use when we have big public place like big metro station or big cinema hall where hundreds of HU are serving to a common area, where we create a mechanical area along the length or along the whole perimeter of the building, and we run the chill water piping network from the secondary loop throughout this mechanical area. Then from the secondary loop we take so many branches to serve a group of HU with the tertiary chill water pump. To be more clear, I draw a simple schematic. You can see in this schematic there is chill water piping network coming from the secondary loop and running throughout the whole mechanical area inside the building. From the supply line of the secondary loop you can see there is branches going to the chill water pump. This chill water pump is in set, one operation, one standby, and serving to the group of HUs after it. This group of HU normally are 2 HU, 3 HU, 4 or 5. The same arrangement will be provided in the mechanical area that we create throughout the length or throughout the perimeter of the large building. I hope now the concept for the tertiary loop working with decoupler line is clear. Now we will go to study the tertiary loop with heat exchanger. Tertiary loop with heat exchanger. This type of tertiary loop normally we use with the district cooling system, or when the chiller plant is supplying the chill water to different buildings that are located in a large area like university or hospitals, or supplying a group of towers that are located far away from the chiller plant. In this type of chill water piping system, normally we have big quantity of chill water to flow through the secondary chill water piping network. In order to save the cost, we try to minimize the diameter of the chill water pipe in the secondary loop, and to achieve this we select the chill water flow at maximum possible pressure and maximum possible delta T temperature according to the equipment available. And we use heat exchanger at the interface of secondary loop and tertiary loop to avoid the excessive pressurization in zones which don't need high pressure. So in this system, the primary and secondary loop, we design a different parameter than tertiary loop. In primary and secondary loop, the chilled water flow is designed based on maximum possible delta T and maximum possible chilled water pressure inside the loop. And tertiary loop is designed based on normal delta T and normal chilled water pressure to avoid excessive pressure that is not needed there. And the operation in primary and secondary loop is exactly same as in primary and secondary chill water pumping system we already studied in part 2. The only difference is that in primary and secondary chill water pumping system, the two-way valve receive the signal from the thermostat located at space and control the chill water flow through HU. Here, the two-way valve receive the signal from the heat exchanger and control the chill water flow through the heat exchanger. The tertiary loop has its independent chill water piping network that transfer its heat to the secondary loop through heat exchanger and maintain its chill water flow through it as per the space requirement through the operation of two-way valve and variable frequency drive with the help of variable speed chill water pump. So now we can summarize our study as for primary, secondary and tertiary chill water pumping system, we can divide it into two parts. One is with decoupler line and the another is with heat exchanger at the interface of secondary and tertiary loop. The design parameter for the system based on decoupler line is same inside the building and the chiller plant, whereas the design parameter in the system based on heat exchanger we have different design parameter for chiller plant and the secondary loop than the design parameter inside the building. So friends, I hope now the concept for primary, secondary and tertiary chill water pumping system is clear. And if you like my video, then please share it with your friends, and still if you have not subscribed to my channel, please subscribe it so that I can bring more videos for you. Again, I want to say thank you to be with us for this study and hope we will be together in the next study for primary, secondary, tertiary chill water pumping system part 4. Thank you very much.